Hello, welcome to Enlightning. Thank you so much for being here. I'm here with Joni here today. Joni, will you introduce yourself, please?
Hey, I'm Jonathan, also known as Johnny, and I am one of the engineers of the Spring engineering team. I work on all things observability. I'm also part of the team called Spring Observability team. And other than that, I am also like one of the leaders of the Seattle Java user group and one of the maintainers of Micrometer, which I believe we are going to talk about today.
We're going to talk about Micrometer today. So you've been on Enlightning once before, I guess over a year ago, a long time ago, and you talked about just what is observability generally.
Exactly, yes.
So I'm so excited to have you back and talk more about what it means to add observability to applications, because
Thank you for having me.
Yeah. So let's go ahead and dig in. Let me give you some context. I'm doing a whole series of Enlightening shows on observability tooling, and I focused on CNCF observability tooling generally. But what I'm learning is I thought observability had more to do with the network layer, like infrastructure, like a service mesh capturing metrics that's happening. And what I'm learning, even just from the first few episodes of covering CNCF observability, is that there's actually a lot to do with developers and instrumenting applications to be able to add observability. And so you're here to talk about Micrometer specifically, which is amazing, but also in general, I'm just very fascinated to hear about why developers are instrumenting applications and how are they doing it and what improvements are being made in that area. Meanwhile, Epic Tralala's here. Hello, friends. Thanks for coming. So glad to have you. What else do I need to know going into this conversation? What's some good background knowledge before we jump into Micrometer?
So one thing that you mentioned, I believe that's very important. Like network observability, it's an important thing. Today, what we are going to talk about is mostly like application observability. Because how they are communicating over the network or what your like network devices are doing, it's like pretty crucial. But what your applications are actually doing, that's like I believe equally important.
Yeah.
Like knowing like I remember like when I started doing observability at that time, this was not called observability. But basically how you called it, hey, I want to know what my application is doing in production.
Okay.
I don't want to deploy my app so that I don't know what is happening with it. I don't know when it is down. I don't know when it is slow. I don't know when it is like giving hard time to my users.
Okay.
And that was basically like observability back in the days, like years ago, 10 plus, easily. I believe we can start with like a recap, a few things about like what is observability, why do we need it, and so on. So let's talk about what is observability. In the first place, because I believe giving a definition is rather important going forward. Because a lot of times people are saying, hey, observability is just like logging metrics and distributed tracing. And from my perspective or my opinion about this, it's like observability is it's like so much more than that. Logging metrics and distributed tracing are very crucial like signals to have observability, but we have like so much more other than that. So usually how I define observability is basically like how well you can understand the internals of a system based on the outputs that it provides. So basically your application is providing like meaningful information about what is happening inside. And I believe I can like summarize this in just a few words.
So don't write how well you can understand.
You can actually, but it is basically just a fancy word or like a fancy like sentence or definition or all of those things. It's just a fancy way of saying observability is really data about your application.
Okay.
And what kind of data? Any kind of data. So I usually would say that what is observability? It's data about your app. If you are talking about application observability, of course. Yeah,
I
and
want to.
if you imagine it, yes,
Yeah.
sorry, go ahead.
Oh, I just wanted to say hi to. This is Fuel Snowball. Hello, Fuel Snowball. Did I just out you? But so I used to be streaming to Twitch. Yes.
Mm-hmm.
And I stopped doing Twitch because it was just like, So thank you, Fuel Snowball, for coming on over to YouTube. And I love that Fuel Snowball is here because Fuel Snowball is an application developer, so they can probably weigh in. One thing we're talking about is, I have a question before, like we're talking about app observability versus network observability. Is it an either or thing, or is it something you should have both?
No, it's something you usually should have both. Like whenever a failure can arise or something, an incident can arise that can give you like a hard time in production or any environments, you usually need observability there. But like network observability was I believe like the on the network stack, this was like maybe a little bit easier because like network was not as like fragmented, I believe, as the application space. And like if I go back to the old days when we had like monitorings, we like used to monitor like network infrastructure, I think way better than we used to monitor applications. Also, like monitoring networks can also like include application monitoring a little bit because like applications are also like sitting on the network. So I don't think it's like an either or thing. It is like you need both.
Okay, that's great to know. Thank you. So observability is data about your app. You mentioned it's logs, metrics, traces, and so much more, you said.
And so much more. Yes. So that's what like that data, it can be anything. A lot of times it's like logging, metrics, tracing. But for example, like knowing like what version of the JVM you are using. It's a pretty nice information to know. So that also like, is it like logging, metrics, or distributed tracing? No, it's none of them. Which version of Spring Boot are you using in production? Which version of your application is deployed? Like, is it 1-1 or 1-2? There are a lot of details. Or how many like CPUs or resources can this application can see or use? For example, if you are running in a Kubernetes cluster. Because what you set in Kubernetes, that might not be the same what your application can see. So there are a lot of details, like other details that you can provide. Observability space doesn't like stop there, but these are the three main signals, and we can talk about those as well a little bit. Also, in the meantime, yes.
Martine has a question. Any tips on how to control the cost of observability?
That's a very extremely loaded question.
Yeah, I think we can do a whole episode about that.
There are many things, like most of the time. So let's just talk about like logging, metrics, and distributed tracing in like in this context. So for logging, basically like controlling the cost means like controlling the amount of the data that you publish to your observability backends, whether it is like self-hosted or like hosted by some companies or vendors. And basically with logging, you can reduce the amount of data by setting so-called like log levels, or like disable certain loggers, so that you will have less logs. But that means like you will have less data. So there is a trade-off here. Less data, less information, less observable applications. For metrics, usually metric libraries will give you a chance to like remove like whole metric families from your system, like not recording them, even if like some components are wants to do that. You have usually a chance to ignore them. And also you can basically like add or remove metadata as well. which means that you will have like less time series. And for distributed tracing, you can do this as well, like basically like ignoring like complete spans or maybe like complete traces as well. But also for distributed tracing, there is a thing called sampling. And sampling is rather important because distributed tracing is like a lot of like data, and you might not want to like send all of the data to your backend. Maybe you do if you have like very light traffic. Like, I don't know, like 2 users are using your application like sometimes. But if you have like thousands of requests processed, maybe you just want like 1% or 10% or 0.0001% of your traffic sent to your distributed tracing backend. So these are the main things that you can use to cost control. There are other tricks as well, but these are the big ones.
It all seems to boil down to how to collect less data, how to store less data.
Yes, it is.
And then I imagine there are all kinds of techniques in terms of what you decide to keep and what you decide to get rid of. And it would be dependent upon the situation, like your particular application and situation.
Yes.
Yeah.
Okay. So let's also talk about why do we need it now that we know like what is this. And in one word, I would say we need observability because of complexity. And I guess that's a really good recap for this like question. Why do we need observability? Because of complexity. Because today's systems are insanely complex as of today. Like, we have like thousands of applications.
Yeah.
And these environments can be like very chaotic. And we need to deal with unknown unknowns. Which is like, there can be things in production that you don't even know about they exist, but they can bring your production environment down. And also, to make this a little bit worse, sometimes things can be perceived like differently by different observers, which means that it can happen that from your perspective, your production environment seems like 100% okay, and it's green, and you're happy with it. But at the same time, maybe everything is broken for your users.
Yeah.
So observability is basically like meant to solve these problems, and we need this because of complexity. Actually, there is like another fold of this. Like, why do we need observability from the business perspective? And from the business perspective, I guess the one word answer to that question is because of money. So it's complexity and money, because observability can help you to reduce like loss of revenue from production incidents. And also it requires like less specialized knowledge, because you have just like one set of tools, for example, that you can use for all of your applications. And you don't need this like special tool to just like look at into one special app, or this tribal knowledge of, hey, these are like apps are like communicating this way and so on. And you can also like quantify this like user experience. So you can basically like measure it, not just guess about it.
So we need observability to better understand our wildly complex systems. And we also need observability because of money.
To save money, basically, like on production incidents and on because if you have like so this means that if you are able to like identify problems like faster, because your like systems are like better observable, usually you are able to fix those incidents faster. So loss of revenue is less.
So specifically, we're saving money because we're able to recover from
incidents faster. Yes.
Okay. Maybe this isn't worth writing on the board, but it also seems like you would save money if you could have a good understanding of why an incident happened, so that way you can make sure it doesn't happen again.
Never happens again. Yes, that's a really good point. Yes.
So you can recover faster, but you can prevent them maybe too.
Yes.
Right.
And I believe this is like a really, really good point. I usually don't emphasize enough. So thank you for it. And I believe this can resonate with a lot of people. I guess like most of the people who worked at mid or big size companies have seen this. That, for example, their application were using like I don't know, HTTPS with a certificate that expired. Every single year there is some news that, hey, there is a multi-billion-dollar company who lost a lot of like money because of like an expired cert. And that's a really, really easy way to fix. Like, just like, give me a new certificate before it expires. Observability, for example, can solve that, because if you know that the certificate will expire, for example, next month, then you can take action before it becomes a problem. So saving money to like, because of like, you will know if upfront that there will be a problem, it's a really good thing to have.
It's hard. It may be a hard sell because you want to believe you're not going to have a problem, as if know, even though it's wrong,
So there is a very, very good like a solution for that, like to see, just wait. Because there will be a problem at one point. If you are in the business for a while, and if you don't believe that this will help you, just wait, because production incidents will happen. When the first production incident happened, that you will think that, hey, I could have like basically prevented it, or like would have been like able to like troubleshoot it faster. Just think about this, that, hey, what would have happened if I had like proper observability? And maybe if you like take actions and introduce it, then next time it could be easier.
Martina has a good point too, which is faster recovery can minimize brand damage.
Yes.
So that's brilliant. And if you're in the YouTube chat, he went through about what he's been doing with observability, which it sounds like reducing retention of logs in particular, and then introducing a long-term cheap storage solution.
Yes, that is also it's a thing. Like basically, when you, for example, like send your logs to a log ingestion system, like to a backend, like one feature of it is basically like storing them. But another more important feature is that you can, like, it will index it and you can search it. For example, how many errors did I have? How many errors did I have that contains that error message, and so on. And that is a little bit more like costly. And if you can have like a log, like if you can like retire your logs, you can basically like say that, hey, I have like a retention policy. I only want to keep logs from the last, like, I don't know, 30 days, 6 months, whatever. And after that, archive them, which means that I will not be able to search them immediately. But if I want, I can basically like restore them from the archive and like search them if I want to, or like search in like a more like expensive way in terms of like time. But I don't really need those. Usually. So that's where like this like log retention policies can help.
Fascinating. Cool. Awesome. So we talked about what observability is. We talked about why we need it. Yep. Is there any other context we need?
Let's also talk about these three like big signals: logging, metrics, and distributed tracing.
Okay.
Because like I don't really want to talk about right now like what are those, or what they are really doing here. If you want that context, I guess like watch our recording like 2 years ago or so. I talked about that. But I want to like talk about a very important thing, that these signals can be connected. They can like work together. And by what I mean, so by this like interoperability of logging metrics and distributed tracing, is that you can jump between these signals. Like you can like jump from logging to traces. If you see a log message in your log ingestion system in your log backend, if you have a thing called log correlation, that means that the tracing information in your logs, and the tracing information is usually like 2 IDs, and you can use that ID, usually it is called a trace ID, to just copy the trace ID from your log message, go to your distributed tracing system and search for that ID. And it can bring up the very same operation that happened when you emitted that log message. So I believe I would put this maybe on the whiteboard, like some interoperability, I would call it maybe.
Oh, I was going to say they should be correlated with one another.
Yes, they are. Like that is also called like correlation ID. So, and the feature called log correlation. Yes.
So is that the point you're making now? Is that logs, metrics, and tracing should be correlated with one another?
Yes. Yes.
That's something you need to do deliberately. And I've also heard, we talked about this in a recent episode. One guest, Adriana, said she doesn't like the,
or
Adriana Villala. That's how I say her last name. I think that's a very westernized way to say her last name. But she said these are often referred to as the 3 pillars, but she doesn't like that idea because pillars imply that they're so separate from one another, and really they're correlated. They should be correlated. I think of it as a braid.
I like that. That is my opinion too. I don't like the name 3 pillars, not just because like it like suggests that they are separated, but also because they like it suggests that this is the solution and that's where you stop. Like observability is so much more than these. Like the 3 pillars, yes, they are the 3 big signals, but there are more things. So you should not stop there.
Okay, so so this is interesting because she said this too, but you're kind of getting into how they're actually correlated, and I think that's pretty fascinating. It's so let's maybe draw a little thing. So if we have logs, like logs are somehow related to metrics, which is somehow related to tracing, and you're going to tell me about that.
Yes.
Cool.
Yeah, so between like logs and traces, you can jump like there and back. So I believe that if I would like throw an arrow between them, that arrow goes to both ways. And you can use like the same concept to jump between them, and that is the trace ID.
Okay.
And the trace ID is like this correlation ID that you can have like in both places, so that you can basically just like copy paste it and search in one another. There are also like, by the way, there are also backends who has like these, like in one product, for example, Grafana does this, that you can just like press like one button, which is pretty nice. If it can find like a trace ID in your logs, it will give you a button that, hey, do you want to jump into the distributed tracing view?
Cool.
So let's also talk about like how to jump between or from traces to metrics.
Okay, traces to metrics. Okay. I'm listening.
So if you want to jump, because like there is a huge difference between jumping from traces to metrics or the other way. It's a lot different. For logs and traces, there is no difference. It's just a trace ID. But if you want to jump from traces to metrics, that's the easier thing to do, because you can jump like using a technique or like a concept called common tags.
Common tags.
And common tags is basically just a concept of having the same tags on your distributed tracing spans and on your metrics. For example, like the HTTP status code. If they have the same like key, like, I don't know, status code, and the same value, I don't know, 200, then you can basically just get these values and from your span, and you can just craft a query in your metrics backend.
Okay. This is awesome. So when you say have the same tags on your traces, do you specifically mean on spans?
Yes, on spans.
Okay.
It is also very important, I believe, here to mention that on your metrics, you cannot have high cardinality tags. But this is basically like a detail of this. The interesting thing is that if you have the same metadata on them, then you can basically just get the metadata from your span and basically craft a query using that metadata so that you can have the metrics. And if you think about the concept, the question you are asking by doing this is basically, okay, I am seeing like one operation here, or something happened in my application. How can I get all of the other operations and aggregate them together based on some things that are similar to this one? Okay, I can see like a 404 where on this endpoint where, I don't know, the HTTP method was get. How can I get all of the like some information about all of the other events that are similar to this? And the answer is that, hey, you can get this metadata and you can basically craft a query with it. And this is kind of like an easy thing to do. The hard thing is going back, like the other way, from metrics to traces. Because there, the question is basically, hey, I have like, let's say that you have like a metric about like you're monitoring the latency. And you can say that, hey, I have now like a peak in my graph. And that is saying like, hey, the latency there, the maximum latency was like 200 milliseconds. The problem is that this number, 200 milliseconds, it's an aggregated number. It consists of many, many things aggregated together. If in that time range you, I don't know, like processed 1 million requests, those 1 million requests were basically like aggregated the data of them to one number.
Yeah.
So you are basically like using data. And the question is like, how can you jump back from that one number, 200, to back to one of those like 1 million requests? Not like, usually like not to any of them, but like some of them. Just show me just a few examples.
Yeah.
And right now the industry's answer to that, it is called the technique exemplars.
Exemplars.
So that's the thing that you can use to jump. And exemplars are basically like metadata that you record when you basically record your metrics. And they can contain the trace ID and the span ID as well. So when you like recorded your metrics, those data points can contain these exemplars, which is like the trace ID and span ID usually in this context. And you can attach that to your values. So when you say that, hey, the latency here was 200 milliseconds, you can also attach this data point that, hey, for like, there was at least like one data point where the trace ID and the span ID was this when we aggregated this with this value. So yeah, that's basically the gist of it. From logs to traces, that's the trace ID, and back. From traces to metrics, common tags. From metrics to traces, it's exemplars.
And I would like to define exemplars again, because it's the first I've heard of this concept. So what is an exemplar? Yeah.
An exemplar is basically a metadata
Okay.
that you attach to your metric values.
Okay. And do you attach it to all of them or some of them?
So it is sampled.
Okay.
And so it is some of them, because there will be like metrics that it doesn't make sense to attach exemplars.
Okay.
Or that metadata will not be available at all. But you are basically attaching these to the value, and that's a very important like there is some like nuance here, because when I say like attaching to this metadata to the value, that part, the value, is very important, because exemplar can have like high cardinality data. That means it cannot be like a metric dimension. It is basically, if you like if you record like something that, hey, a latency event or like an event happened in my application. It was like a get request to this endpoint. It was HTTP 200, and the latency was, I don't know, 110 milliseconds. Then next to this 110 milliseconds, the value you attach the exemplar, not to the dimensions, because the dimensions the text must be low cardinality, and the exemplar is not. So it is basically extending the value of a metric. It is attaching like some extra information to the value, and you are sampling it, and you are basically like just like dropping these things like as you record things.
Exemplars extend metrics. I can spell exemplars. Whatever. Exemplars extend metrics. To correlate them with traces.
Yes.
Is that accurate?
Yes.
And Martina has a question for you. Are the exemplars indexed or just a payload? Metric dimension is what I mean by indexed.
Yes, I believe this is what we just answered, that it is not indexed. This is not a dimension. It is something that you attach to the value. If you mean like a payload by the value that you recorded, then yes, it is attached to it.
Okay.
I believe this is a very, very important question, and this is a very, very important distinction. Because if you want to like attach the trace ID and the span ID as dimensions, you will basically have like problems very, very, very quickly, because exemplars are like high cardinality data, and that will like blow your applications out from its memory and your metrics backend from its like disk space and memory. It's something that is sampled and attached to the value, and basically that's it. So
now I have between logs and metrics.
Let's talk about that, because like what you can do there, if you want to jump between logs and metrics, is that since you can jump from logs to traces and metrics and back and forth, you can basically like use that. Like you can basically jump from logs to metrics by like doing a stop at traces.
Okay.
Sometimes though, like it's like you don't. So in order to do this, you don't necessarily need to go to like a distributed tracing backend if you don't want to, because like logs can have those common tags as well. Usually they don't. So if you want to do it, usually you need to stop at traces, but it's not always a must or a have to. But with exemplars, since you can get like the trace ID, you can just like go to your logging backend and just search for it. So it doesn't it's not a necessity, but it is usually the same concept. Jumping from logs to metrics and back based on the same concept that you are using to jump between logs and traces to metrics and vice versa.
So use traces to correlate logs and metrics.
Yes.
Excellent. Oh, this is great. Cool.
So
we have, yeah.
Let's after this, let's talk about what you can do in your applications. For example, like JVM based applications mainly, if you want to implement these.
Okay. This is like the meat of it. So this in particular, when you say how to implement this, like how to collect logs, metrics, and traces, as well as correlate.
Both. Like when you are basically like so for example, so when you want to implement logging metrics and distributed tracing, and you want to like collect this information and ship to somewhere, that information that you publish or ship to somewhere, that needs to contain the correlation information as well. So this is both.
So basically, when instrument your JVM application to collect and correlate logs, metrics, and traces.
Yes.
Okay. Cool. All right. How do we do that? It should be simple. I want a one-line answer.
So on the JVM, like if you, for example, like want to like use or like you want to do logging, then usually on the JVM the answer is SLF4J. And SLF4J stands for Simple Logging Facade for Java. And it's like a very simple project that gives you like a simple API that you can use. And you can use SLF4J to plug like logging libraries in and out. And like one logging library that is very popular, it is called Logback, which is like a native implementation of SLF4J. So for example, if you are using Spring Boot on the JVM, this is what you will get out of the box: support for SLF4J and Logback. And you can use like other logging libraries like Log4j. It is basically just like excluding a dependency and including another one. But SLF4J plus Logback is usually the go-to solution if you are, for example, using Spring Boot.
Logback, Logback?
Yes.
And Logback is what?
So SLF4J is the facade. It is basically the API, and the Logback you can think about like an implementation. Like it's like a logging library.
Okay.
So I would phrase like what you write like SLF4J is a simple API for like emitting logs and or recording logs, and Logback is like a library that will do the work basically.
Okay. Simple API to record logs. And then the most popular logging library receives the logs and puts them somewhere? What does it do?
So how it looks like is like the SLF4J will basically give you the API layer, and Logback is the implementation. That implements that API. And the magical thing here is that, hey, if you, for example, like don't like Logback, you can just remove it and put another implementation into it.
And
so I would say, yeah, so go ahead.
JVM specific.
Yes, these are JVM specific. Like this is like JVM application observability. Yes.
Cool. So instrument your JVM application to collect and correlate logs. You probably want to use these tools or tools like them, but you're going to need, and this is for logs specifically, right?
Yes.
So we still have to worry about metrics and traces.
Yes. So if you, for example, like using like Spring Boot, then like you will get these with Spring Boot out of the box. You don't need to worry about like, hey, I need like put SLF4J and put log back onto my class path. They are already there. Spring Boot gives you auto configuration for logging, and it will do logging for you out of the box using these two. And I believe that should be the case if you are using like other frameworks on the JVM as well. These are like very, very popular like libraries.
Okay.
So let's talk about metrics, like what you can do on the JVM if you want to instrument metrics. And for metrics, we usually recommend using Micrometer.
Oh, there it is.
Yes, we are getting
there. Okay.
So Micrometer is basically a dimensional metrics library on the JVM. And we kind of like having here the same situation, or like a similar situation what we had with SLF4J. That it is like Micrometer has like a API that is independent of the configured metrics backend. Like you are just using like one API, and then you can decide like, hey, my metrics should go to Prometheus, my metrics should go to I don't know, InfluxDB or Elasticsearch or like whatever you want to. And you can actually like use like multiple backends at the same time as well. So you can use like Prometheus and JMX, or Prometheus and like InfluxDB and so on. And in order to do this, you don't need to change your instrumentation. In order to like decide like what like backend you want to use, you don't really need to change your application or like the code of your application, what contains the instrumentation. Also, just to talk a little bit about some like Spring Boot like ties here as well. Spring Boot actuator comes like pre-configured with Micrometer. So if you are using Spring Boot actuator, that you are getting Micrometer as well out of the box. And most of the Spring projects, they are instrumented using Micrometer. And there are many third-party libraries that are also using Micrometer to instrument themselves. If you go to the Micrometer website, micrometer.io, you will find like some notes about instrumentation, and you will find like a long list of projects that are instrumented with Micrometer.
Is it instrumented? Should I say Spring Boot is instrumented with Micrometer, or can I just say Spring Boot has Micrometer?
I would just say like Spring is instrumented with Micrometer.
Okay.
Because like Spring Framework is instrumented with it, Spring Data, Spring Cloud, Spring Security is also instrumented with it. Basically, all of the big Spring projects, they contain instrumentation, and they are instrumenting themselves using Micrometer.
And so that just is happening. Like you don't even do anything. It's out of the box.
You don't. It's out of the box. It is automatically instrumented. Sometimes, in some cases, you need to enable it.
Okay.
Because like those are the use cases where you might not want instrumentation to give instrumentation to the people out of the box, because like those use cases are very like performance like specific, and the instrumentation also have some performance cost. So for example, if you're using like Spring Kafka or Spring RabbitMQ, Instrumentation is not enabled by default.
Yeah.
But it is usually just a config flag, like, hey, enable instrumentation for Spring Kafka true. That's all.
Okay.
So instrumentation might not be there like active out of the box, but it is there out of the box, maybe doing nothing and saving you some like CPU cycles. But if you want the data, you can get the data by turning it on.
Okay. And you were saying something about third-party tools.
Yes, so there are many libraries and frameworks like outside of this Spring portfolio, like Quarkus instrumented itself with the Micrometer, Micronaut as well, Hibernate, Hickory CP. There are all of the big libraries that you would use as a Java developer. There is a very high chance that they have instrumentation using Micrometer.
Okay, cool. So many Spring-related tools are instrumented with Micrometer. Most, can I say most?
So yeah, most of the Spring portfolio and many things that are not even Spring related.
Most Java related.
Yes. I believe that is, we can say that most of the Java related libraries that are used today have some sort of instrumentation using Micrometer.
Can I just say use my Micrometer?
Mm-hmm. Cool. So let's talk about distributed tracing as well. The third thing after like looking at metrics, because like, so for distributed tracing, we usually recommend a library called Micrometer Tracing. But let me give you some history of Micrometer Tracing.
Quick question.
Yes,
is this enough room to write about tracing, or should I start a new column for tracing?
I believe
is it a little thing or a long thing?
I believe that's fine. Because like what I would like to record there is basically the name of the project, which is Micrometer Tracing, and basically like 2 libraries that you can use with them. And one of them is Brave, the other one is OpenTelemetry. So this is basically, you can recap this whole thing in just 3 words.
So Micrometer Tracing, right?
Yes.
Is it, and that's the name of a tool?
That's the name of the project, yes.
Okay. And 3 words. Yeah.
So, but let me give you some like history behind it a little bit, and we don't need to like record this on the on the board, because like when I believe it was like almost 10 years ago, 9 years ago, it was like in 2015, Spring Cloud like introduced a new project for distributed tracing, and that it was called Spring Cloud Sleuth. And Sleuth was started back then, and that's how you get like distributed tracing support for Spring, but only for Spring. Spring Cloud Sleuth was a Spring library. It did not work with anything else other than like you needed Spring Boot as well to use it. So if you wanted to like use or like implement distributed tracing with Spring applications up until like 3 years ago, my answer for that would be, hey, use Spring Cloud Sleuth. That is the distributed tracing support for Spring Boot 2 applications. So when we released Spring Boot 3, what we also did, we got the code base of Sleuth and moved under the Micrometer umbrella. So we basically, what we did, we removed like the Spring dependencies. So Micrometer Tracing is not Spring dependent anymore. It can work with any JVM application. So that's basically Micrometer Tracing. It's Sleuth without the Spring dependencies. We also like renamed a few packages, but all of the concepts that you got used to using Sleuth, they are exactly the same in Micrometer Tracing as well.
Okay.
And micrometer tracing is basically, it's again, like I am going back to that SLF4J situation. It is basically a facade for tracing libraries. So what you can do is you can have like a underlying library, like just the SLF4J and logback case, and you can replace them and you can switch between them as you want. So one of these libraries that's like micrometer tracing supports, it is called Brave.
Okay.
And the other one is OpenTelemetry. So Brave is like a mature like tracing library from the OpenZipKing community. And we usually say that this is kind of the default, except there is no default because you need to choose. And OpenTelemetry is a CNCF project. And it is like a little bit more like experimental because OpenTelemetry is not 100% like stable yet. But yeah, that's basically the two things that micrometer tracing supports. One of Brave and the other one is Octal, and you can switch between them. And that switch is basically should be like very smooth. Like you don't need to change your like instrumentation code.
Example libraries: Brave and OpenTelemetry.
Yes, and Octal.
Which I'm calling Octal.
Yep.
Cool.
So that's basically it. If you are like on the JVM, that's what we usually recommend to use. And this is what you can get out of the box as well. Like if you are using like a Spring Boot, then you can get auto configuration for all of these. And also like instrumentation too, because as I said, these like projects, they are like this Spring portfolio, they are instrumented. And they are using these libraries to provide you like enough observability information about your applications.
So if I'm a developer and I've never added observability to my apps before, and I decide I want to start, what's the onboarding experience like? Are these pretty like intuitive and usable immediately, or is there a lot to know? Are there good resources?
So that's the goal, to make this like very, very lightweight for you. On the other hand, like if you want to use like these concepts, you need to know about them. You need to understand them. So the onboarding experience, like the easiest thing that you can do is basically if you add Spring Boot actuator to like your class path, to your Spring Boot app, then you will get support for all of these. And from that, you need to decide then like where you want to ship this data. So you basically need to write some configuration. If the by default console is not good enough, then you need to write this to a file, ship to like a load ingestion system and so on. So that is basically a config file. For metrics, you usually need to decide which backend you want to use. If you want to use Prometheus, you need to get like a dependency for Prometheus. If you want to use Elasticsearch, then you need to get dependency for. So you need to make this decision. Hey, this is my metrics backend. This is where I want to ship the data to. But if you like want to like implement metrics, you already need that to set up somewhere. Plus, you can like define a few properties that, hey, this is the URL of my metrics backends where Micrometer should send the data. And that's the same with tracing, basically. Like you need to define like which library you want to use, Brave or Octal. And then you need to like define like, hey, this is my backend that I want to use, and just set a few properties. So if you go to start.spring.io, And if you like start typing like maybe like metrics or like for like metrics backend, like if you start typing, for example, Prometheus, it will add all of those things to that like example project that you need. And for metrics, it is usually like one dependency plus like Spring Boot actuator. For tracing, you usually like need like two dependencies. One of them is the tracing library, it's Brave or Hotel, and also the underlying like exporter that you want to use.
Cool.
So it's not very, very complicated, but you will need these backends. If you want to see like a full-fledged like application, if you find me on GitHub, on github.com, I have a repository called T-House. And T-House is basically doing this. Like it is, it consists of like 3 applications that they are like talking to each other. And there is also like a Docker file, not a Docker file, like a Docker compose file, which will give you like a Grafana's log ingestion system. It will give you Prometheus, and it will also give you Grafana's distributed tracing system. Those are called like Loki and Tempo. You will see that in my in that repo. So that is basically setting up the backends for you, and in the application you can see like what does it take to use those.
Is the link you shared with me earlier relevant now? The
developers.com? Yes, because if you go to that site, on the sidebar there will be like a link to my GitHub account. And you will see the repository is called T-House. Yeah, just feel free to use it. Also, if you go to the talks section of that site, I am showcasing that application, like live demoing it on like many conferences. So if you go to those talks and you can just like spot like a video, like you can see like talks from like DevNexus or Spring.io. Those are showing this thing. So if you want to like see an example, like what works like out of the box for you, and it is like it's like very opinionated because I needed to pick like a metrics backend and other things as well. Then you can see like how to do that in like real life JVM applications.
Amazing. All right, what's next?
Okay, so this is basically the big deal.
The big deal.
Yes.
Okay.
So because like if you want to do all of these, and let's say that you want to instrument your components, maybe those are like homegrown components, or maybe it is your business logic. There will be a point in your life when like out of the box instrumentation will not be enough.
Okay.
Like if you have like a piece of business logic that you want to instrument, nobody will instrument it for you. You are the only one who can instrument it.
Yeah.
If you want to add logging, metrics, and distributed tracing, then you need to do this instrumentation like 3 times, right? You add logs, then you add metrics, then you add distributed tracing.
Yeah.
So that's one thing. This is a lot of boilerplate. Another thing is that let's say that you like started like instrumenting your application, you added logs and you added metrics, and you are happy you deployed it to production. And then you realize that, hey, I want to add distributed tracing as well. Then you need to modify the original component, add it and deploy it. And that's not that's a lot of boilerplate, and it is kind of like cumbersome.
Okay.
Especially if you think about it, that when you add like this instrumentation, a lot of time you are dealing with some like instrumenting some events that are happening in your app that has some duration. So usually what you do with metrics, you are starting a timer, executing your business logic, and stopping a timer. If you're instrumenting with distributed tracing, you're doing the very, very similar thing. You're starting a span, doing your things, and stopping a span. And in the meantime, you are basically like attaching some like metadata, handling errors, and so on. So the problem is that we need to add separate instrumentation for each signal. And that's only the 3 big signals. You can also have like custom things. Like if an event happens, I want to, I don't know, write some data into an audit table. That's not even 3. We are at 4 things. And so on. You can have like 5, as many. So that's why, like, when I mentioned like it's not necessarily like 3 pillars, it can boil down to this problem as well, that you need to constantly add the instrumentation for like different things as you want to record and basically like output some data. Does this problem statement make sense?
It sounds tedious.
Yeah.
As heck.
Okay.
So tedious. Yeah.
So we have a solution for this.
I thought you maybe did. Usually people don't say this is a big problem and then just leave it at that.
Well, like I only know like 1, maybe 2 things that are doing like this or similar to solve this. Most like as of today, it is still like a lot of times as people are instrumenting their components, they are doing these things separately.
Interesting.
So this is still not a very, very like widespread thing that I am going to talk about. It is starting to be very popular on the JVM. Elsewhere, not so much. But like the solution we came up like with in order to solve this like instrumenting operations that has some duration, that's basically the problem here. When was it? I believe it was almost like 3 years ago. I believe it will be 3 years in November. When Spring Boot 3 was released, actually that was the same time when Micrometer tracing was released, we also released a new set of API under Micrometer called the Observation API.
Observation API.
Yes, and that's what I would like to talk about, because that's something like can be like very, very interesting to you if you are using Java or like any JVM languages.
Observation API.
Yes.
Cool. I'm listening.
So the promise here is basically you have one API, not 3, 4, 5, or 6. And you can instrument your code once and get multiple benefits out of it. So you can instrument your components once using one API.
Once and get many benefits.
Yes.
And we're going to list the benefits, right?
Yes, we will. Like actually, like benefits or like saying like outputs, it's the same thing, because like what the Observation API is do, like when I mentioned like a few minutes ago that when you like do this instrumentation for like metrics and tracing, you are basically like starting a timer and stopping a timer, and also starting a span and stopping a span. Here, you are starting an observation and stopping an observation.
Okay.
And so this is basically like 2 very like simple operations that you can use like with an observation, like start and stop. You can also signal an error on an observation. You can also signal other arbitrary events on observations.
I
would just list
stop
these, like start, stop, error, arbitrary events. These are the big things that you can signal.
Okay, you can signal. Start, stop, error.
And arbitrary events, yes. Or you can just say events.
Too late. All right.
And you can also attach metadata to these observations. And you can also tell if this metadata is low or high cardinality. So I would say like attaching low/high cardinality metadata. And
what does that mean? You've said it a few times.
Like metadata, basically arbitrary like key pairs. Like
cardinality.
For example, cardinality. Okay, let's talk about cardinality. That's an important topic. So I actually, like, if you go to that like website, like developers.com, I have a article there. I believe it is titled High Cardinality. And that will explain the concept of cardinality and what is low and high cardinality means. Now, the cardinality is basically coming from math. It is basically the number of elements in a set. So if you have like a set with one element, the cardinality of that set is 1. If you have 100 elements, the cardinality of set is 100.
Okay.
So the problem that you need to solve with cardinality is that, let's say that you want to, let me give you an example. Let's say you want to record metrics. And you also want to like aggregate like how many times somebody called your application on HTTP. And you want some metadata. So you want not just like, hey, my application was called like, I don't know, 10 times in the past minute or the past hour. You also want to know, okay, which endpoints were called. What was the HTTP status code? What was the HTTP method? And so on. So, for example, let's say that you want to first track the HTTP methods. And you are saying, I have get, post, delete, put, and let's say everything else is unsupported. So I have 5 different HTTP methods. So if you want to track like all these 5 like different methods, you will need 5 different counters. You are counting get separately, post separately, and so on. So from 1, cardinality of 1, we went up to 5.
Okay.
Let's say that you also have like 10 different HTTP endpoints. I have /users. Let's say you are selling cars. I have like /cars. I have /orders, whatever. You have 10 of them. That's also like 10 counters, right? Except if you want to also record like get requests
every 5
to the cars and one, that's like not 10 or not plus 10, times 10. So we jumped from 1 to 10 to 50. Now let's say that you want to add the HTTP status code and you have like 20 HTTP status codes. We are like basically like right now at 1,000 different counters.
Yeah.
And that can like, this is like still not high cardinality because it is like well bounded. 1,000 counters, it's not really a lot. Your metric system and your application will be able to handle it like pretty easily. But the interesting thing is that let's say that you are tracking the full URL like of the endpoint. It's not just like /car, but less /car/the ID of the car, for example, or /users/ the user ID. The problem is that if you have like 10 million users, and if you put this data, then you will have like 10 million times like 1,000, that's 10 billion. Wow. Different counters. That's high cardinality. Yeah. That's something. So basically, and it is actually like a little bit worse because maybe you have 10 million users, but if I have like a random number generator and starting hitting your application /user/1, 2, 3, and so on with all of the numbers I can run in that time section, you have like pretty quickly get into a problem of trying to solve trying to store infinite amount of data in non-infinite amount of space, which is your memory or your disk.
Yeah,
that's a problem. That's what high cardinality is problematic, and high cardinality is like a problem for metrics. It is not a problem for logs because you will not have basically a different like if you like make like if you attach like more metadata, or if the cardinality like explodes, your time series in your metrics will also explode. That's not really the case for tracing and logs. They are meant to handle high cardinality data. Logs are not. Logs are meant to handle low cardinality data. And just to just go ahead.
Something else I wanted to talk about. You're talking about a unit called an observation. Can you say what that is?
So the observation is basically a concept for recording your operations. It is basically something that you can like interact with, so that later on you can produce some outputs that you want. And let me go to there, and it will be like easier to grasp why is it or what you can do with the observation API. Because if you just do this, like what we like wrote or what you wrote on the table, like you start an observation, if there was an error, or signal it, you add like metadata, and then you stop the observation. Okay, but what will happen? Okay, because if you, for example, like emit like a log message, you know like what will happen. Like there will be a log message in your logs. If you like create a span, you know what will happen. That span will like be part of a trace, and that will be published into your distributed tracing backend. But what will happen when you start and stop an observation? And that is like the key like of this whole API, and that is the heart of it, because by default, nothing. It is just instrumented. What will happen like when you start an observation? Nothing, because you did not tell me what to do when an observation was started. So there are these things in the observation, or there is this interface in the observation API called the observation handler. And that is a very important component, because this is kind of like a listener which can listen to these events. When you start an observation, the handler will be notified that, hey, somebody just started an observation. When you start that observation, the handler will get a notification that, hey, somebody stopped that observation. And what the handler can do, it can record this data and present it in a form that you want. For example, when somebody started an observation, you can have a metrics handler that can start and stop a timer when you started and stopped an observation. If you have a tracing handler, you can have like as many handlers as you want. It can start and stop spans when you start and stop an observation. And the key thing is, you just start and stop the observation. You have the instrumentation once. You don't need to touch it in order to add like behavior to it. You can do it runtime later using this observation handler, because they will listen to these events and they record the data that you want.
So an observation is a time-based construct.
Yes. It is to basically record events, like time-based events in your app. That something happened.
Okay. To define an event, to record an event?
Record, yes. I would use the, or you can also like use the word observe, but maybe that would be overloaded.
Okay. So an observation is a time-based construct to record an event, and then with that observation, you can do something with the observation handler.
Yes. So the handler basically does like two things. One, listens to these observation events, and the other is creates the desired output, or records and creates the desired data or output.
To one, listen for, whatever, listen for relevant events.
Yes.
And then two, do something.
And the other one is basically like records the data and creates the desired outputs.
Oh. That's a little confusing because it sounds, it sounds like the observation itself is recording an event, but it's not. It's the handler's recording the data.
So with the observation, you are basically like using this like start, stop, error method to record what happened. And you will basically like use this information and transform it into some form of data. For example, metrics. So the data of what you have like on the two sides are a little bit different. On one side, you have like the event that is happening. That's the reality that is happening here in your app. And the other side, you will have some kind of output that you want. For example, metrics or distributed tracing or logging or whatever you can imagine. And I will also talk about that a little bit. So does this make sense? Like what is happening here? Because like just go ahead.
So for example, someone starts a checkout, and then that makes the observation handler start recording data, right?
Yes.
And then it would record data. Maybe you have it set to record data until the checkout process is finished. And so now then the observation handler is going to do something with all that data. It's going to make, here's a trace of what that looked like. Here's all the logs that happened during that time.
Yes.
Here are the metrics during that time.
Exactly.
Okay.
So if you want to go like into like a little bit details on that what's happening if you have this, like, let's say you have this process or operation called checkout. When you instrument it, you will have start an observation for this checkout process, run the checkout process. If there was an exception, then signal that on the observation. And at the end, when the whole thing, like the checkout process, like stopped, you stop an observation. And in the meantime, you can like attach like this arbitrary metadata about the checkout process, like what was the user, who checked out, which products were checked out, and so on, whatever is relevant to you or to your business to observe them. So now that you have this and instrumented this, you don't necessarily need to add modify this instrumentation if you just want to get this like logging metrics or distributed tracing benefits out of it. Because now that you have this observation that starts and stops when somebody starts and stops as a checkout, you can just add a metrics handler, and the handler will say, hey, somebody started a checkout, let me start a timer for that. Somebody stopped the checkout, let me stop that timer for you, and bam, I have metrics. And if you decide that, hey, this is good, I have metrics, let me also add distributed tracing. What you can do, you don't need to modify the instrumentation. The observation is already there. You just need to convert that information to distributed tracing by saying, hey, let me add another handler. And the another handler can basically start a span when somebody starts a checkout and stop the span when somebody stops to check out. So that is basically the gist of it. That's how we are trying to solve this problem of one, having one API, and two, if you want just to add like another signal or like another like output, you don't need to re-instrument things. You don't need to modify the code. And this is extremely useful if you have, for example, third-party components. Because what you can have, like, hey, I am using this like HTTP like client. And let's say that HTTP client that you cannot touch because it's like an open source library somewhere, it is, let's say it is instrumented and it has metrics, but you also need like, for example, distributed tracing for it. What you do? You somehow like need to modify it or wrap it or like work around things. With the Observation API, if that HTTP client is instrumented, with the Observation API, you can decide runtime, hey, I need metrics. That's great. I just attach the metrics handler. If I need tracing, that's great. I just attach the like the tracing handler. You don't need to basically like touch the instrumentation that is there, built in, baked in with all the data that you need. You just like receive that, transform it into some form, metrics, tracing, logs, whatever, and emit it.
That's brilliant. Not only does it reduce the toil, but then like if you have different personas who need to be doing different things, like maybe your developer just wants to write business logic and it's someone else's job to figure out.
Yes.
Everything around.
Let me give you some like weird or wild examples, because I was also always fascinated about like open source like tools, technologies, libraries that are like very, very hackable, which means that some people created it once for some purpose. And then other people like used it for like very, very extreme and interesting things and ways that the original authors like did not even think about it. And that actually happened with the Observation API. So the original like thought of this API wasn't like just like logging metrics and distributed tracing, because like we were like ready, like, hey, like let's try to like record anything that the user wants and basically create any output that the user wants. And like I had like an example like years ago that, hey, what if like this happens in my application and I want to record it and I want to, for example, like add like a row into an audit database table. If I want to do this without the Observation API, I need to write it, modify the instrumentation. Again, like I'm in this problem. With the Observation API, it's amazing because I can just put like another handler to it, which will do the, hey, this is the data. I am recording that this is happening, writing this to the database. I'm done. So there was somebody who integrated the Observation API with the async profiler, which is like really great. It's just like a profiler output for the Observation API. There was somebody on Twitter who said, I'm not sure if he has done it, but I believe it must be possible, that, hey, I want to record observations during my tests, and I want to create UML sequence diagrams based on these observations, basically a picture about what happened in my application, that you can saw these components and arrows are running in between them, which was like amazing to me. Like, what?
Wow.
So I believe it was like a year ago or so. Yes, I guess it was like DevNexus last year when I came home from DevNexus, and I was thinking about, okay, like I have a bunch of like data about my app that I can see. Can I do like crazy things with it? So with this, or like other crazy things with it. Let me put it that way. Which I am not going to demo this, but if like it's on YouTube. If you watch like the Spring IO talk that we did with Tommy Ludwig this year, it was like 2 months ago. You will see this in action. So what I did, I wrote an observation handler, which was create. You know what MIDI is, right?
Yeah.
You were in a band.
Yes.
So MIDI, just for the others who are listening and don't necessarily know about MIDI. MIDI is basically a musical like an interface for musical instruments.
Yeah.
And Java has MIDI support, which means like it will not play like an instrument by default. It is just like playing the sounds on your speakers. So what I did, I basically created an observation handler, which measured the duration when you start and stop the observation. And at the end, when it measured it, it basically played a random drum when there was an incoming HTTP request for the time, for the duration, what that processing the request took. And if this happened to be a error, then it played the French horn. And I also added like two more observation handlers. One of them did, if there was a database call from the application, that it played, I believe it was the bass guitar. The same thing, just play the bass for the duration of the database call. And if there was like an HTTP request, an outgoing HTTP request, it played the piano. So when I had this and hit this with a load balancer, sorry, not a load balancer, a load generator, that was basically like hitting this application with I heard like music. There was like random music playing the drums, the bass guitar, and the piano. And the interesting thing was, like, because the load generator also generated errors once in a while, I was able to hear when there was an error because the French horn blew in. And that was like very, very apparent. I was able to hear not just the traffic patterns, like how much traffic do I have, because like how much times the drum basically like hits, but also how much error do I have. So if I basically like fix all the errors, the French horn go away. If everything was an error, no drums, just French horn. And I also like what I also did, because like all of the notes that the application was playing through the observation API, through these observation handlers, were like the duration of a note was the duration of like that event happening. If I introduced latency between the database and the application, the whole application slowed down. I was able to hear that on the music, because the music also slowed down. I was able to hear the application like really, really struggling.
Wow.
And the music was like just like very, very like slowing down instead of having like a fast pace.
Yeah. That's
and it was amazing.
Yeah, like a more visceral like feeling than if you see like a visual graph and you can see it slows down, like you can tell. But like to actually have like the beat of the music slow, like that's like, yes. Or like something as jarring as a French horn, or yes. I'm almost imagining like in the ops room, there's like an air horn that goes off whenever an error happens. Yes.
I am like, not saying that you should do this in production, but it was like a really nice like demo, and like people like really liked it.
That's awesome.
So that is basically like a very, very good example, or like I think for the sheer power of the observation API, because now the output of this observability data, everything that you recorded, is basically music. Well, music, actually, it's not too bad because I use like the pentatonic scale. So it is actually at least like harmonizes, and it is not as random as I expected when I first like heard it. I was like, this is actually not as bad as I thought. But it's quite random.
So I don't have a sense of how much you wanted. Did I write too small and we have a lot of extra room?
That's totally fine. There are like, four more things I would like to cover.
Okay. Those I didn't write small enough.
No. So those are like small things. That's fine. We can we have like plenty space for those things.
One thing we talked about, but I haven't captured, is we talked about like what this is, but we haven't really like spelled out what the benefits are of doing it this way. Do you want to take some time to do that, or is that coming up, or do you have other stuff you'd rather cover?
The benefits are actually like we like sort of like captured it a little. Like one is like you have like one API, and the other one is that you only need to instrument things once. So that is basically the huge deal, that you don't need to touch the code that is instrumented or like that you are observing or recording data about if you want to give more information about it. For example, if you just want like logging, then you just attach a logging handler. If you want metrics, you attach a logging and a metrics handler, and so on, and you are accumulate these handlers.
So that, and you kind of, when we talked about the problem, we talked about this, but only instrumenting once is like reduces the toil of instrumentation, but then also if you want to add more handlers, you can just add more handlers versus before when you would have to go re-instrument to add whatever else you needed to do.
So before this, if you don't have the observation API and if you want to attach or like add like additional behavior or additional outputs, then you need to touch the instrumentation code. And that's not always possible. Like in the HTTP client example, for example, if you are using like an open source library and that is also already instrumented, I don't know, like with logs and metrics, and you need like distributed tracing, that's a problem because you cannot really like touch it. You need somehow like work it around.
Okay. So only instrumenting once. Is that really, I mean, do you think that's it, or is there more you want to say about it?
I believe that's most of it. Another interesting aspect of this instrumentation, when I mentioned these low high cardinality things, that basically drives your hand. Because if you are, for example, like instrumenting something, and if you start like adding metadata, you can get into this trap of adding high cardinality data to your metrics without thinking about. Because the observation API will force you to classify that metadata. Is it low or is it high cardinality? You are forced to think about it. So it's like easier to instrument, less code to write, less toy, less boilerplate, and also you can just add like behavior to like produce some output easily. I believe these are the main things.
When you add behavior,
like
is this? Yeah, I don't quite understand.
Emitting logs, outputting metrics, outputting distributed tracing, that so on.
Okay.
Oh, we have a question.
We do, yes. Christian, we have a couple. So Christian Summer asked maybe we can talk about how instrumentation works, hooking on system calls or specifics of the Java virtual machine. I guess, do you understand the question better than I do? Hi, Christian, by the way. Good to see you again.
I believe like how that works, he means the observation API. Because if so, that doesn't really have like any JVM specific thing other than it's like it's a Java library. But what you can do is basically like you have like an API that you can use to capture what is happening inside of your application for time-based events. Like if something is happening, you are doing like a checkout or like a user registration or whatever, or anything that is like an event, and it can have a duration, you can capture that event using the observation API. I hope this gives you like a good gist of the whole thing.
Bo's question is more, can we get Hans Zimmer? Can we get like a famous composer in to give us some DevOps music?
I hope I have like a good answer to this, because when I did this like the demo for the observation API and this music demo especially, I did it like back in April on DevNexus.
Okay.
One of my friend Erin Schnabel, you know her.
Yeah,
she had a complaint that she was quite disappointed that I did not rickroll the whole audience. So next time when I did this talk together with Tommy on Spring.io, in the meantime, I implemented another observation handler where the music wasn't random. the notes of that were like played, like when like an event was happening, it was basically just saying like, hey, give me a note that I want to play. And the list of the notes were basically Rick Ashley's music. Like it was never gonna give you up. Yes. So it was basically me, like the whole application, it had like it has a UI, and basically you can request a tea recipe. So as I pressed the button, basically there was like an HTTP request, and that basically like triggered like playing one note. So as I pressed it, press with like a certain rhythm, it was playing the Rick Ashley song. So I basically recalled, I believe like around like 200 people on scale in masses. Yeah. So yeah, you can definitely do it, and it is not Hans Zimmer, it is Rick Ashley, but it is in that tea house application. You can replace. So there is basically like a section. There is like an array of like musical notes, basically with their names. So C, B, like A, B, C, whatever. You can replace it to whatever you want, and it will play your music.
I'm moving these out to be in here because this is taking up space if we have 3 things. So what would you like to talk about next?
So actually, I want to talk about like 4 things. All of them are like linked to this observation API. Basically, other things that you can do with this, but 2 of them is pretty short. The other 1, 2 are like a little bit longer, but I believe like we have like plenty space on the whiteboard for capturing them. It's not a lot. So the first thing I want to talk about is like it is called the observation predicate. And the problem that it is trying to solve, it is also part of the observation API. So let's say that you have like a third-party component instrumented with the observation API. And it is basically like records observations. What if you don't want that observation? How can you ignore it? Because the handlers will be notified that, hey, I am having this observation, so let me like do my thing and record metrics, tracing, play music, whatever. So the observation predicate is basically a component that you can say that, hey, I want to ignore this observation, or I want to accept this observation. And that's basically it. It's a very, very simple component. You can write like a one-liner, like Java code, to say that, hey, whenever an observation happens with these properties, I want it or I don't want it.
So you can, I'm just trying to think of how to be.
I believe to ignore observations.
That's better. To ignore or accept, right?
Yes. Accepting is easy. You just don't need to do anything. So it is basically like an active thing from your side if you want to like purposefully ignore things. This is also can be like an answer to that cost-cutting concern that we talked about earlier. That you can say that, hey, and actually like I did this like in like on workshops as well. And I believe my my application is not doing this, but for example, if you are using like a Spring Boot, because the Spring portfolio, so when I mentioned earlier that the Spring portfolio is instrumented with Micrometer, I meant this API. This is part of Micrometer, and the Spring portfolio is instrumented. Basically, everything in Spring is instrumented using the observation API. And sometimes this can be overwhelming. You might not want all of the data. For example, like when I do demos and I have or like a workshop, and I also have like Spring Security active. Spring Security is also instrumented. And it will give you a lot of information. And Spring Security is turned on. The instrumentation is turned on by default. So the observation predicate is a good way to saying, hey, right now, I don't need this data. And I want to like ignore it. You can do this with basically anything that can emit observation data, because you can identify those observations that you don't need by name, by type, by whatever. And you can say, I want this and I don't want this. So it's a nice component to help you to select what you want as an output and what you don't.
Makes sense.
So that's one thing out of the 4. So the other one, what I want to talk about is called an observation filter.
Is this a component too?
This is also a component. It's like an observation predicate, except it is called observation filter. And the name of it might be a little bit misleading, because you would think as a filter acting like filtering them out or in, but that's not what this name filter suggests. The observation filter is basically a component that you can use to modify your observations.
Okay.
So an example for that is let's say that you have, again, like a component sitting somewhere, like an HTTP client library that you are using in your application. And what you can do with an observation filter is to receive these observations, and you can basically tweak them. You can modify them. You can add data. You can also remove data. So let's say that the observation have like a tag, like some metadata that is it is still, let's say, low cardinality, but it is too high for you. You can use the observation filter to remove that. Or let's say that a tag is missing that you want to add. For example, the name of your application. That's when somebody recorded the observation with that inside of that HTTP client. They did not know what is the name of the observation that is used by millions of users. Everyone has different application. So you can use an observation filter to add details, remove details, basically modify and transform the whole observation as you go in runtime.
Add tags at less than cardinality for the example.
You can also broader cardinality if you want. That's up to you. You can do whatever. Yeah. If you want to shoot yourself on the foot, this is a great component to do that.
If you want to make your life harder than it already is, use the observation filter.
Yes. It is also great, for example, to say that, hey, the instrumentation uses or has some the name of the observation is something, or some arbitrary tags are has this name or this value. You can modify that as well. You say hey, the instrumentation for this HTTP client library, it is using status for the HTTP status code, and I want to use status code. You can rename it. And does this make sense?
Yeah, you can kind of change the whole functionality of the observation.
Yes, you can basically inject things that will actively transform this data and add new things or remove existing things or modify things.
Add, remove, modify functionality.
Yes, and I believe this, the use cases here can be very, very common. That hey, I want to add a common tag for all of my observations. For example, what is the name of my application? Or can be very, very narrow. For example, I found a bug in one of the distributed, I believe it was this, yes, it's one of the distributed tracing backends that was accepting a certain tag, a certain value, or with a certain value. And that's just not what my output looked like. So I was able to basically just use the observation filter and add that thing as well, or modify that thing in a form that basically that system was expecting. Or you can use this.
Again, you don't have to touch your application code.
Nope.
Which is
you don't need to. You don't.
All the logic
this is
separate
kind
from
of
the
like application code, but like you are not touching the instrumentation.
Yeah.
Like when you created the observation, started and stopped it, and add all of this data, you don't need to touch it. You can modify that without touching it, because before like the handlers will like act on that data, the filter will be in the middle, and it will just like modify things if you need to.
Cool. All right.
So this actually like one of the use case of the filter, like renaming things, or like basically like using like different names for like the observation or for like tags. That brings us to like another, like a little bit broader use case that is covered by the next component, the third one, which is called observation convention.
We're getting... Okay.
So the observation convention is basically all about naming things. So when I mentioned this use case, when I had this problem with the distributed tracing backend, which like accepted like one name, or like one name of a certain tag, or like let's say that the instrumentation in some client library is using the name of the tag status for the status code, but let's say all of your dashboards are using status code and accepting it. So one thing that you can do, you can write an observation filter for that. But if you want to modify this like in a broader sense, you can write an observation convention. And what the observation convention does, it lets you choose how things are named runtime instead of hard coding that name. So instead of hard coding the name, you can say that, hey, I have one naming convention and I want to replace it to another. Like let's say whoever instrumented that component, it used like one naming convention, but I'm also able to just like swap that naming convention for a different one. And this is awesome if you are doing like some migration work, saying that, hey, I have, let me give you like a very good like real life example. When we introduced this whole thing with Spring Boot, we created a naming convention, which was the naming convention that was the same with Spring Boot 2. So when Boot 3 was released, we used the same naming convention what Boot 2 used, because that is how like this is a breaking change. We consider this as a breaking change. We will not break you, but we will let you to modify this, but just by like using a different naming convention. And there are like different ones. Like your company might have one. Like, hey, these are my dashboards. All of them are expecting like this to have this name. You can basically just saying that, hey, I have my own naming convention. Let me inject it, and Boot will like basically back off. It will say that, hey, I am not using the default naming convention. I am using the one that you provide for me. So we are using your name for these concepts. And this is interesting. For example, if you want to use like OpenTelemetry, OpenTelemetry has semantic conventions for many things, which might not be the same as the Boot naming conventions, for example. So if you want to move from the Spring Boot out of the box default instrumentation naming conventions to OpenTelemetry, you can just write an observation convention and tell how things are called. Like that's basically it. That's the observation convention. You tell your instrumentation how things are called. How to call the HTTP status code. Is it status? Is it status code? Is it http.status? Is it http.code? Is it something else? Like, what is the name? So that's what the convention can tell you. And that's what the instrumentation is using. So when you create an observation, you can also say that, hey, create this observation with a default convention that I provide, But if the user provides one, let's use that one instead. So this is a really, really great thing for like flexibility amongst like naming, because we all know naming is extremely hard. So what we do with the observation API is letting you to define like a default name for things. But if like somebody wants to name them differently, they just create a convention. They just say, hey, I want to use this convention, and that's it.
And it like allows for change. When things inevitably change, then here's an easier way to fix it than going back through all of your code. And yes.
And the whole thing can be just like a one-liner, like to change this, like saying that, hey, I am using the default convention. Now I am migrating to like a different convention. That's like a breaking change. I think I am ready for it. Let me deploy it to like a staging environment. Nope, my dashboards are broken. Let's go back.
Yeah.
So you can basically like switch easily.
Yeah. Awesome. Is the fourth thing also a component?
Yes, that is also a component. That is called observation documentation. And this is kind of like a two-in-one thing, because observation documentation is in fact a component of the observation API. But there is one interesting use case of it, which is a different like library. And that is called Micrometer Docs Gen. And I am going to talk about that as well once we talked about what is this observation documentation thing.
Okay, it is an observation API component.
Yes.
And what does it do?
So the observation documentation basically helps you to keep the documentation in sync with the implementation. So what it does is when you say that this is the name of the observation according to your convention, or this is how I want to use the HTTP status code, you usually like hard code things there. Like it's just a string. With the observation documentation, you can basically like have enums. And the interesting thing is that when you basically like create observations using this observation documentation, like what the convention will use this documentation, they play together nicely. And they are saying that, hey, please documentation tell me how to call this like component, like HTTP status code. And we have this like separate project called Micrometer Docs Gen or Docs Generator. What it can do, it can scan these observation documentations and it can generate real like text documentation about your instrumentation. It can tell you that, hey, you have instrumentation for this HTTP client. This will be the name of the metric. This will be the name of the span. And these are the tags or like the metadata that you have next to it.
It's called the Micrometer Docs Generator?
Micrometer Docs Generator. Yes, that's the name of the project.
Okay. So if you have documentation, then you change the name. You can change it very easily with your naming, and then also that name will easily change throughout your documentation, removing a ton of
and it will basically it will generate you like an ASCII doctor file that you can convert it to like very, very easily to HTML. So when you instrument a component, it will be also like an HTML page, an output, what the data that you can get out from that component. So when you are like an ops person and say like, hey, like what are the important things that or I can get out from this application? The application tell you by just like generating this documentation page or like a whole site with all of those pages that can tell you that, hey, you will have these observations. And these are the important things that you can watch. And it is not just like the name of them, but because this is also like integrated with Java Docs, if you put like Java doc like comments on these like Micrometer documentation components, like, hey, this is the HTTP status code documentation, whatever comment you make there, it will go to the HTML output. So it's a pretty nice way to keep your reality, which is your instrumentation, in sync with your documentation, what you wrote down, that what you think the reality is, because this will always keep them in sync. When you change something in your instrumentation, then or like in your observation convention, that will go to your docs.
Okay.
Which is a really nice thing to have. And so how these components work together. And also there is like one more interesting thing of this observation documentation. It makes things type safe. Like if you are using like a type safe language like Java, you can like appreciate it that you don't need to deal with strings anymore. So for example, if you mistype something, the compiler will let you know, because you will use like a enum instance instead of like just doing a string.
And then you said it's a 2-for-1?
2 for...
At the beginning, you said observation documentation component is like 2 in 1.
Two because like one is the observation documentation itself. That's what you use in your app. And the Micrometer docs generator is the library that you can use build time to use these observation documentation components and generate like an ASCII doctor and eventually like an HTML output.
Cool. So it generates the documentation, keeps it in sync, adds type safety.
Yes.
Amazing. Cool.
If you want to like see, because like all of these things, what I talked about, a lot of like libraries and frameworks that are instrumented, they are using these. So if you, for example, like look into the instrumentation of Spring, you will see these like concepts that, hey, Spring is creating an observation using a documentation with like a default convention, letting you like injecting another convention, starting the observation, stopping it, signaling an error, and so on. You will see many, many real life examples there. If you want to see some kind of like a demo or a little bit more details about how these things like work or look like, or what their outputs look like in real life, then there was a Spring I/O talk this year in 2024 done by Tommy Ludwig and me. On YouTube, just like search either for my name and Spring I/O or for Tommy's name, Tommy Ludwig with W.
Let me turn. I'm going to turn the displays names on so people can see your name and how it's spelled. Yeah.
Cool. So yeah, that's my Twitter handle. You will find it from there as well. Also, if you go to the website developers.com, it has a talk section, and that can also take you to the Spring I/O side. And I believe the video should be linked there. If it won't be, I will put it into the talk section. But we are basically like demoing these concepts by using, like, you will see the code as well. Like you will see like, hey, what to do if you want to just set an observation, how to start and stop it with like in kind of like a real life setup inside of code, and how to add things like in addition, because you don't necessarily need to use these if you don't want to. Like you can create an observation without a convention. That is just basically saying that I don't want anyone to be able to replace the naming what I am using, which is, if you have like a library that is used by a lot of people, maybe it's not a too smart thing to do, but it's not a must. You can use the observation API with or without it, and you will see like a real time like how to add things if you want to add these capabilities to your observations. So we demoed this like on Spring I/O this year, and I think I will have a talk about this on Spring 1 this year. Excellent. Like in end of August. I as far as I know, I have like at least one talk about these like problem set and topics. Maybe 2. Let's see.
And my understanding is that it will be virtual. So even if you're not planning to go in person,
yes, you can listen.
You can listen to Joni's talk about Micrometer and the Observation API.
Yes.
We have one little line of space. Should I just put like the Micrometer website down there, or do you have a takeaway thing you want me to write here?
And I guess that's very important, because like if you want to also use this and like add this to your like applications, I would start at the documentation side. You will read about these concepts in like more details with like real life code examples. You will see those there, and it's micrometer.io.
Cool. So the way I like to wrap this up, if you have, I can't believe we fit it all. It's perfect. It's like we planned it. Micrometer.io.
Yes.
I would like to go through and recap everything you've taught me today. Almost everything we've written on this board is new to me. So I love to say it again and make sure I have a clear understanding, and we together as a community have a clear understanding. So first,
I would also encourage the people who are watching this to ask questions. Like in the meantime, I believe that leave a comment. In the meantime, you are like doing the recap, because I believe that's a good way to go through again everything and think about if there is a concept you did not understand, or you have like any questions about it. Yeah, just feel free.
That is a great point. Yes, please be liberal with questions. So we did a lot of context, which is great. So what is observability? And the bottom line is that it's data about your app. There's logs, metrics, and tracing, but there's also so much more. So when you said so much more, you talked about like versions of things, versions of JVM, versions of your particular application, versions of Spring Boot. There's also another example of something that doesn't fall in logs, metrics, or traces would be resource utilization. So there's so much more. But we need observability for a couple of reasons. One is our systems have become wildly complex. So to begin to understand those, we need observability. And then we also need observability to save money, and specifically to save money by recovering from failures faster and learning from the failures so we can prevent them in the future. And then we've talked before on the show about how your logs, metrics, and traces should be correlated. But what I love is we got into the specifics of how exactly they should be correlated. So we have traces, logs, and metrics. Traces and logs can go back and forth, can be jumped to one another with using a trace ID. And then we talked about traces and metrics. And so you can jump from traces to metrics using common tags. So you have the same tags that on both your spans and on your metrics. And then jumping from metrics to traces is hard, because one number in a metric may represent, you said, like 1 million data points. So how do you go from there to like one little trace, So you said that was done with exemplars, which is metadata that you attach to your metrics values. And so that's how you correlate metrics back to traces. And then to complete the triangle, to correlate logs and metrics, you do that using traces. So that, because everything relates to traces. And I've heard that before too, that of the three pillars, which we also talked about, why that's a bad term, of the signals that the traces tend to be the most utilized and most important if you had to weight them. So then we talked about, okay, now you're a developer. It's your job to instrument your app, your JVM application specifically, to collect these pillars, the logs, metrics, and places, and also to places and traces, and also to correlate these things to one another. So for logs, you probably use an API that's a facade for logging libraries called SLF4J. And if you're in your JVM app, and then the logback is the most popular logging library that you're likely to use. With metrics, we use Micrometer that this episode is about. It's a dimensional metrics library for the JVM. You know what I meant to ask you? What do you mean by dimensional? What does that mean?
Yeah, so there are basically like two different types of metrics libraries or recording this data. One of them is called dimensional, and the other one is called hierarchical. And hierarchical means that basically all of this metadata that you can have in your metrics, that is encoded into the name of it. Like, let's say that you have like a metric called HTTP requests. And you want to add metadata like status code, the HTTP method, and so on. So if this is hierarchical, it will be like, I don't know, HTTP requests dot 200 dot get dot cars, whatever. Or maybe it can be like the name can be there in the name as well, but not necessarily. So that is the hierarchical name, which is like everything is in the name, in the metric. Dimensional means that you will have these key values next to the name of the metric. So every time series basically consists of a name and a set of key values called tags or labels or attributes. Different systems are calling them differently. But that's basically it. If you write this down, represent this as like a string, you will see the different, it will be like very, very apparent. The problem with hierarchical is that it is like much harder to figure out what are the different like fields. They have like their order. You need to like create like some kind of like wildcard or regular expressionist like things in order to query like different type of or like different things and drill down or like narrow these dimensions down. With the dimensional metrics library, that's not the case because you just like mention the name of the tag and you can write the query using it. If you go to micrometer.io to the docs site, there is like a page called concepts, which will talk about this a little bit more details. Maybe we have, I am not 100% sure if we have like an example, like spelling it out, like HTTP requests .200.get. And when you want to query for all the 200s, and it doesn't matter if it is get, put, post, or whatever, you just do like http.get.star for hierarchical. For dimensional, you just mean like, hey, give me like the HTTP where like a request where the status code equals 200.
So if hierarchical is harder to use, why do people choose it over dimensional?
That was the old way of doing this. Like that was like the first thing that was there before. When Micrometer was created back in 2017, as far as I remember, Micrometer was the first like metrics library on the JVM that was hierarchical. Everything else before that, it was dimensional. Sorry, the other way.
Other way around.
Yes, Micrometer was the first like dimensional, and everything else was like hierarchical. And still like like JMX in Java, that is still like hierarchical.
Okay, we took a departure. Thank you for that. So for the metrics, we're talking about instrumenting applications, JVM applications specifically. We talked about logs. Now for the metrics, we use Micrometer, which is a dimensional metrics library for the JVM. So it provides an API that's independent of the metrics backend. So you can use any backend that you want, or you could use different backends at the same time. And Spring is instrumented with Micrometer out of the box. And Micrometer is very popular, so that most of the Java-related libraries today are all use Micrometer. And then we talked about distributed tracing, which you could do with Micrometer tracing, which is a facade for tracing libraries. And example libraries would be Brave or OpenTelemetry. So now the problem is, if this is our process for instrumenting applications to be able to do observability well, our problem is that is a lot of toil to add separate instrumentation for each signal and for other qualities too. Not even if it's extremely tedious. And it also has the problem of once you've instrumented it and then later you like, oh, you know what? There's some more data I want to collect. Then you have to go back and add it again. Like it's tedious. So Micrometer has added the Observation API, which is one API so you can instrument your applications only once. So there's much less toil. So you can signal start, stop, error, and arbitrary events. And you can attach low or high cardinality metadata to an observation. We talked about cardinality kind of being the exponential growth of the amount of data that you could be asking for is the cardinality. It's a metrics problem. So basically with the observation API, you have this construct called an observation, which is a time-based construct where you stop and start. So a checkout might be an observation. Then you use an observation handler. So actually the observation handler listens for the relevant events. So a checkout is started, and then it records data, and then it creates the observation. And then with that observation, that it makes it a desired outcome. So the desired outcome could be collecting logs and sending it to a logging backend, or it could be messing with any of the three signals. But it could be adding metadata that the user came from this place or something like that. Does that capture that part well?
Yes, yes, it says.
Cool. So then we have this observation API. It's awesome because now if we want to collect, we decide later we want to collect more. We don't have to re-instrument the application itself. We can just add different observation handlers. So not only is it less toil to add in the first place, but it's much easier to update, much easier to collect more information. And then we talked about some other components that are related to our observation API. We have an observation predicate, which is an API component to ignore and accept observations, because sometimes you're going to use for example, sometimes you're going to use third-party tools that are already instrumented to collect certain things, and maybe you don't want all those things. So you can use the predicate to ignore some of the things that are being collected. We can use a component called an observation filter to modify observations. So we could do anything here. The sky's the limit. But we could add or remove tags. We could add or lessen cardinality. I don't know why I would add it, but sure. We could add, remove, modify functionality. Oh, you're going to tell me why you want to add it. Why do you want to add it?
That is attaching things like, for example, like high cardinality data. Not to metrics, but for example, like tracing, that could be like an interesting thing. For example, let's say that you have like you're, for example, like using like Spring Security, and you are doing like JWT, like chart-based authentication, and you have some sort of like custom fields in it, because it can contain whatever like data you put into it. If you want to attach that thing to the observation, like Spring Security will not attach it for you because it's your custom thing. You can use an observation filter and get that data out and attach to the observation if you want to.
Cool. Yeah, great. So the observation filter, it seems pretty much like it can do a lot for a lot of different use cases and a lot of different things. It's pretty wildly useful. Then the third observation API component we talked about is an observation convention that's all about naming. So it helps you choose how things are named at runtime. So it's awesome for migration. So we talked about an example where a Spring application out of the box, the Spring Boot naming convention, maybe you want it to be instrumented with OpenTelemetry. So you can just change it to the OpenTelemetry naming convention.
Naming convention, yes. Or your own naming convention that your company has.
Yeah. So you can easily change that. Yes. You don't have to go through the instrumentation itself. You can add the observation convention. And then finally, we talked about observation documentation. So this helps you keep your documentation in sync with the implementation. So Micrometer has a Micrometer docs generator. So you can generate the documentation and then use the observation API component, the observation documentation, to help keep it in sync. So this also can add type safety. And I think that's everything we talked about. Is there anything you'd like to add or anything I missed or didn't quite get right?
I believe that's most of it.
Yep. Most of it.
Oh yeah,
I'll take it.
So the rabbit hole is like extremely deep here. So if you want to do like an 8 hours like stream, I can do an 8 hour stream. If you want to do this on multiple days, it can take multiple days. Like I like on DevNexus and also on Spring.io, like I did 8 hours workshop.
Yeah.
Like covering like not even like these things, like the other things that you can use like in Micrometer, or like some of these things as well, with two of my colleagues, like Scott and Tommy, Scott on DevNexus and Tommy on like Spring.io, and that was like 8 hours. Like
wow,
it's this rabbit hole can go like really deep. But this is basically the big components. These are the basic concepts that you you want to like learn about and know that these things exist, and hopefully you will use them.
This has been so much fun, and I've learned so much. Thank you. I appreciate you very much.
Thank you.
Learn more at micrometer.io, and then Joni's website is Developers,
yes. It's like developers, but it's like an author.
That's what I was picturing. Cool. Well, we're going to dance our goodbyes now. Thank you so much, everyone who stayed with the live stream. And thanks to everyone who watches the recording later. And thank you, Joni, for sharing your time and expertise with us. I thought I pressed play, but I didn't. There it is.
Thank you.
Give me some, just a little bit, Joni. Give me some dance moves. There we go. Bye.